this topic will be derivatives of trig functions. You need to know that these 6 rules. The derivative of sine of any angle is equal to the derivative of the angle times the cosine of the angle. Notice the angle does not change. The derivative of cosine of an angle is negative the derivative of the angle times the sine of the angle. Notice the angles did not change. You take sine of angles, you take cosine of angles, the angles will not change in any of these. The derivative of the tangent of any angle is the derivative of that angle times secant squared of that angle. The angle did not change. The derivative of secant of any angle is the derivative of the angle times secant of the angle times tangent of the angle. What you're taking, the secant and the tan of, is the same as what was on the other side. The angle did not change. The derivative of cosecant of u is negative u prime cosecant u times cotangent u. You take cosecant of angles and cotangent of angles, the same angle you started with. The last one you should know. You should know all these 6 like you know your name. The derivative of cotangent of u is negative u prime cosecant squared of u. Know these definitions. Let's work out some problems using these definitions. If somebody asks you to find the derivative with respect to x of the sine of 3x squared plus 4x plus 5, this here is your u. It's the angle. The derivative of the sine of any angle is the derivative of the angle times the cosine of the same angle. The angle should not change. You take cosine of angle. This angle should be the same as the beginning angle. There's the answer. Maybe we can factor out a 2 from the 6x plus 4. And you would get this. Okay. If you were asked to find the derivative of y equals the secant of 4x squared plus 9 to the 10th power, all of this is the angle. Y prime will equal. The derivative of secant of any angle is the derivative of the angle. A function to the power, we use the general power rule. You keep the base the same, you bring the power up, make a new power 1 more, and you take the derivative of what's inside. 8x. Just 8x. Okay. So far, all we did was take the derivative of the angle. Times the derivative of secant of any angle is the derivative of the angle, which we did, times the secant of that angle, times the tangent of that angle. Like I've been saying, the angle doesn't change. It happens to be 4x squared plus 9 to the 10th power. The derivative of secant of any angle, hard-looking angle or easy-looking angle, is the derivative of the angle times the secant of the angle times the tangent of the angle. If you have a trig function and this angle, and say you have another trig function in this angle, they don't correspond, that is, they don't look exactly like the original angle, you have it wrong. If you're going to make any mistake, don't let it be that one. The angle should not change. Well, what if you have a sum and a product? What if you're asked to find the derivative of y equals, well, we did secant, the cotangent of 4x plus x cubed times sine of x squared. Well, so the derivative, it's the sum of the function. It's one function plus another. So we take the derivative of each term separately. It's the derivative of this plus the derivative of that. The derivative of cotangent of any angle, well, it's negative the derivative of the angle times cosecant squared of the angle. The derivative of cotangent of any angle, let u just stand for any angle. It equals to negative the derivative of the angle times cosecant squared of the angle. You need to know this. Can't play the game unless you know the rules. Okay, that's the derivative of the first term. Plus. Now we have a product. It's x cubed times sine x squared. I like to call this the first, x cubed, and sine x squared the second. The rule says it's the derivative of the first, 3x squared, times the second, which is sine of x squared, plus the first, which is x cubed, times the derivative of the second. The derivative of the sine of any angle is the derivative of the angle, which is 2x, times the cosine of that same angle. The angle never changes. We get negative 4 cosecant squared of 4x plus 3x squared sine of x squared plus 2x times x cubed is 2x to the 4th times cosine of x squared. And there is your answer. It's a case where you use the product rule. If you were asked to find the derivative of y equals 2 sine x cosine x, well, one good way of doing this is to know that that's just sine of 2x. If you know your trig identities, it can eat through this problem. So now we just have to find the derivative of that. Y prime equals the derivative of the sine of any angle is the derivative of that angle, derivative of 2x is 2, times the cosine of the angle. Done. Done. Have to know your identities though. If you didn't know your identities, then you have to use the product rule. Factor out the 2. This is the first function. This is the second function. Derivative of 2 times what's in the bracket is 2 times the derivative of what's in the bracket. The 2 factors out. We have a product here. It's the derivative of the first times the second plus the first sine x times the derivative of the second, which is negative sine x. The derivative of cosine x is negative sine x. And this is 2 times, that's cosine squared x. And the sign here is going to be minus, and sine x times sine x is sine squared x. And just for the record, so you can leave your answers like that, Or you can say that what's in the parentheses, what's in these brackets is just cosine of 2x. That's exactly what we got above. How about we try this one? Suppose you are asked to find the derivative of this. Sine squared x plus cosine squared x. Well, once again, if you know your identities, very simple problem. That always equals 1. Regardless of what x is, it's 1. The sine of 19 degrees squared plus the cosine of that same angle squared, it's 1. One angle will be 119, let it be 119. Sine squared of that angle plus cosine squared of that same angle is always 1. Oh, so you're really asking me to find the derivative of this, which is really the derivative of 1. The derivative of 1 is 0. Problem's done. If you know your trig identities. If you didn't know your trig identities, it's a headache. First thing you should realize is that that 2 up there is shorthand, and I'm not clear why it's so much shorter, but it's shorthand, or it means sine of x all squared. And if that 2 was a 12th, it would mean sine of x to the 12th power. Plus, same argument for cosine squared x. Is cosine of x all squared. The only time that power does not mean the sine of x all to the n is when that power, is when that number is -1. This here means inverse sine. Doesn't mean the reciprocal. It does not mean that. It's just terrible notation. Because it has contradiction. Has an exception. Okay, so let's take the derivative of this and see what we get. Take the derivative of that. Well, you have something to a power. Keep the something the same, play the power game. That is, bring it down, make it 1 less. Times the derivative of what's in there, which is cosine x. Plus, they're a function to a power. Play the game. General power rule game. Bring the power down, make a new power 1 less. Do not forget to take the derivative of what's inside. The power 1 you could ignore. So you have 2 sine x cosine x. And this minus comes out as a minus. And you have 2 cosine x sine x. But remember, this is the same as 2 times sine x times cosine x. Well, this take away the exact same thing is 0. Just like we got 5 minutes ago, if we knew our identities. Let us do a quotient rule problem where we can learn how to use the quotient rule with trig functions, and we could also talk about how we can make the problem a lot easier. So you have sine x over cosine x, and you realize that's tangent x, well then you're done. You should have memorized the derivative of tangent of x. The derivative of tangent of any angle is the derivative of the angle, which is 1 times secant squared of the angle. That is your answer. If you didn't realize that was tangent of x, you have to use the quotient rule. I like to call the top, and the bottom, the bottom. It's the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Well, the derivative of the top, the derivative of sine x is cosine x times the bottom, which is also cosine x, minus the top, which is sine x, times the derivative of the bottom. The derivative of cosine x is minus sine x. And it's all over the bottom squared. This minus comes out in front and makes it a plus. So that minus is no longer there. So now we have cosine x times cosine x, which is cosine squared x, plus sine x times sine x, which is sine squared x. And this is all over cosine squared x. The numerator is 1. We talked about that a little while ago. Sine squared x plus cosine squared x equals 1. Hence, cosine squared x plus sine squared x is 1 over cosine squared x. If you need to see this step, fine. Cosine x is cosine squared x is cosine x times cosine x. That's secant x times that's secant x. Each of these are secant x's. Well, when you multiply secant x's by itself, you get secant squared x. And that's your answer, secant squared x, something we had really quickly as long as we knew our identities. What's the derivative of sine x over cosine x? Well, that's tangent x. So taking the derivative of sine x over cosine x is the same as taking the derivative of tangent x. But the derivative of tangent x is just something we memorized. Okay, there was nothing to do other than to remember things. Sine x over cosine x is tangent x, and the derivative of tangent x is secant squared x. We didn't use a quotient rule, we didn't use a product rule, we didn't use any rule. We just used what we remembered. Okay, if somebody asks you to find the derivative of y equals sine fourth of 3x squared plus 9x, what you should realize is that means sine of 3x squared plus 9x, but not to the fourth power. That is, don't put a 4 there, and that's all. It's everything to the fourth power. That bracket is very important. So the derivative should be routine. It's something to the fourth power. Don't worry yet if that something is complicated looking or easy looking. It doesn't matter. It just doesn't matter. Something to the fourth power. The derivative will be 4 times that same thing to the third power. Now we take into account this, because we have to multiply by the derivative of this. Well, what is the derivative of sine of any angle? It's the derivative of the angle times cosine of that angle. And there's your answer. I'll bring this in front, but I'll also factor out as 3. That is the same as 3 times 2x plus 3. And 4 times that 3 is 12. Times the 2x plus 3. That is, I just multiplied the 4 and the 3 to get 12 times the 2x plus 3. Then I'm going to denote that I'm multiplying by this and then that. In fact, I'll put that first and then this, because this doesn't have our power. If you didn't do it that way, it's fine. Times the sine of 3x squared plus 9x, but the whole thing is being cubed. And there's the answer to that problem. Let's do 1 or 2 implicit problems. Find the derivative implicitly. that is using implicit differentiation. Suppose this equals 2, and you want to find dy dx at the point pi over 2, 0 for that function. Okay. So we take the derivative with respect to x. The derivative of sine of x, well, the derivative of x is 1. Take the derivative of the angle, and it's in terms of x with respect to x times the cosine of the angle. The derivative of sine of any angle is the derivative of the angle times the cosine of the angle. The derivative of sine of any angle is the derivative of the angle, which is 2. It's in terms of y with respect to x times the times negative sine of the angle. Plus times a minus is minus, and then you have the sine of that angle. And whether you think of 2 as a function of x or y, the derivative of 2 is 0. So this really cancels out. Dx over dx is 1. 1 times 1 is 1 times cosine x is just cosine x minus, I'll say that last, 2 times sine 2y times dy dx equal to 0. This take away this is 0. That means they're equal to one another. If you subtract two things and you get 0, they're equal to one another. Okay. I want to solve for dy dx. That is, I just divide both sides by what I don't want. I don't want the 2. I don't want the sine 2y. Do the same to the other side. And there is what dy dx equals. Top right, please. We just don't want any old dy dx. We want dy dx when x is pi over 2 and y is 0. So I recopy this, and instead of x I put pi over 2, and instead of y I put 0. I get cosine of x, which I write this way, divided by 2 times sine of 2y. It turns out that the cosine of pi over 2, well, here's pi. Pi over 2 is in the middle. It's in the middle of 0 and pi. It's right there, just where the curve is. It's 0. Cosine of pi over 2 is 0. And 2 times 0, well, that's 0. And the sine of 0 is also 0. So you have 2 times 0, which is 0. The answer is the derivative is not defined there. It's 0 over 0. Okay. Let us try another type of problem. What if you were asked to graph the sum of, say, 2 trig functions? That is, you're asked to graph the sine of x plus sine of 2x plus the sine of 2x. In fact, let us make that 3. And you wanted to graph it on the interval 0 to 2 pi. Well, let's do this. The sine, so is this function plus that function. I'm going to add those, and each function corresponds to a graph. A graph usually corresponds to a function corresponds to a graph. Remember, not every graph is a function. Okay. To make my life easier, instead of having 3 sine x, let's have 2 sine x. In fact, even this won't work. But let's have 2 sine x. -1, -2, -3, 1, 2, 3. And to do these easily, you need to think of it. 2 sine x, well, that's just a regular sine graph, and the highest value and the lowest value is 2. That graph looks like that. Okay. The sine of 2x, I mean, for the first one, the sine of x, well, when the angle goes between 0 and 2 pi, you have 1 period of a sine graph. Well, x goes between 0 and 2 pi. The next one, the angle is 2x. Well, when that goes between 0 and 2 pi, you have 1 full sine graph. Well, let's see what x goes between. 0 over 2 is 0, and 2 pi over 2 is pi. That is, when x goes between 0 and pi, you have 1 full sine graph. And there's an understood 1 in front. So between 0 and pi, I draw 1 full sine graph, and my height only goes up to 1. And it goes down to -1. Okay, that's 1 full sine graph. And here will be my next one. Between 0 and 2 pi, it has 2 of these. Well, when x is 0, when x is 0, both graphs are 0. The black graph and the blue graph are both 0. 0 plus 0 is 0. So I get a 0 here. Now, for this x value right here, the blue graph is at 0, and the black graph is at 1. 0 plus 1 is 1. So the sum graph is going to be right there. Okay. Now at pi, both the black graph and the blue graph are at 0. And when you add them, because it tells me to add them, you get 0. Okay. At this x value here, the blue graph is at 0, and the black graph is at -1. 0 plus -1 is -1. So I'm going to be here. And again, at 2 pi, they're both 0. So I'm going to be here. Now, let us talk about, say, these points. The first point that I drew, this one here, let's concentrate on the black graph. The black graph, we see what it is. The blue graph is positive. That is, it's giving me something. It's making it even more than the black graph. So, I go like that. I'm always a little bit more, but at the end, at the highest point, I'm at 1. Now, let's look at, actually, let's not look at the values that I said. First, we talked about this interval between 0 and that first x. Now let's talk about here. Let's talk about that interval. The black graph is positive, but the blue graph is always negative. if you have a positive, but it's always more positive. The black graph is always more positive. It's very hard. Now, if you have a positive value, a large positive value, and you take away, you add a negative value, you got smaller. That is, over that, in this interval on the x's, I'm always going to be a little bit less than the black graph. But nonetheless, I meet up at 0. Now let's talk about this interval. The black graph is always negative. The blue graph is always positive, but not as positive as the black graph is negative. If you're negative and you add a small positive number, you're less negative. That is, it goes like this. It goes like this. Now, over this interval, the black graph is negative, and the blue graph is also negative. That is, even more negative. Okay, I have to be even more negative. But I have to cross at 0. And there's a good graph of the sum, the one that's in red. Okay, there's a nice graph of it. Nothing perfect, but it shows that you understand what's going on. Okay, that completes the section on trig functions and their derivatives.